I started recording then, supposedly. Okay, so I'm gonna start share screen right after I get everything open. Actually, supposedly you're in Dynamic Planet last year, but I'm supposed to explain the rules.
Oh, I wasn't on that planet last year.
I'm supposed to explain it. Everything's
Okay.
already recording. Yeah. I'll just share screen because I don't believe anything. I think you see it, my screen. Wait,
It should.
I'm pretty sure you should
Yes,
see
I
it.
do.
Okay, I don't like the scroll at all. Okay, so Dynamic Planet is right here. So Dynamic Planet is like the shortest rules, and basically it's pretty simple for Dynamic Planet. You get a binder. It's basically a it says 2 inch or 2 inch or smaller 3 ring binder, but from my experience, you pretty much only need a 1 inch. The like extra weight inside the binder is usually filled with older tests. The test of those older tests that you add to your binder, they should be like tests you do yourselves rather than like find online, get the answer key. That doesn't really help you learn it. You should like take the test, correct the test, and then keep like then like that corrected version of the test where you like after like you did the test, you corrected it in red, you then put it inside your binder because then you actually like remember what you missed or something. Someone's actually on here.
Thank
Oh,
God.
so well, we're up to two people, so I have to like re-explain everything. So
I
Daniel, you're on, right?
think I never done it last year.
Hi.
So we have two people. That's perfectly fine. That's actually more turnout rate than my other classes.
Congratulations.
Okay, so basically
Yeah, I think
to
we had it
re-explain, everything's
last.
recorded right now, but to like basically re-explain is that basically Dynamic Planet is like a 2 inch binder basically event. And in the 2 inch, of course, you have like that like big part about the information you gathered, but like the other part should be spent on like previous tests. These previous tests shouldn't be like grab like the answer key, put the answer key in. It should be like tests you actually do yourselves and then like actually like correct so you actually remember the information and where it's located. So like it's like 10 times easier for you to find it. And it's just the previous tests are usually because they don't reuse questions, they reuse knowledge, which is pretty much why you can do it from one thing to another. Like an example would be like say wait, what is this? Waves, motion, height, wavelengths, period. These not that. Basically this waves, motion, height, and wavelength and period. These four are pretty much copy and pasted onto a diagram every dynamic test. So that's one example where it could come into play. That and then another place where you might reuse older tests comes in the form of like well, it comes in the form of diagrams. So like with these topographic features, these topographic features are actually like usually they require you to do a diagram, and like half of the time they've probably reused a diagram from previous competition. So that's one example, and that's basically the construction of your binder in one. You could bring a calculator, but like there's no need for it. And it for oceanography, and it's supposed to be the same event for oceanography this year and next year. It wouldn't matter. It just a calculator is like if you're trying to calculate wavelength and period, but it's most basic math of anything. You could even do in your head. And then besides that, you see the topics for oceanography that we're having here, and the key most times there's gonna be like two parts. Most tests. I'm not sure about like all of them, but there's like you have like a multiple choice part that's a given and a short answer. There will sometimes the part that may be a little difficult is diagram identification slash you drawing a diagram. That those two things, that the diagram identification Diagram identification comes in play with features on the ocean floor. I need to find that. Pretty sure you guys already like. I'm pretty sure I'm supposed to explain everything though, even though you guys probably seen this before. Oh yeah, and I'm pretty sure this is like the old dynamic binder we created. I'm pretty sure you guys have access to this. Do you guys?
Yes,
Do you guys have access to this
Yes.
fiche? Yeah,
garage.
yeah. I'm pretty sure we're supposed to. Nothing's printing though. Wait, is this literally? Wait, what happened to everything on here?
Also, we've already started a new binder.
Yeah, I know you
I
guys
think
probably
you
did.
just have to like wait.
You sure you have to wait? I'm pretty sure my computer's.
I'm gonna share it now.
Oh well, I made a copy of that binder too, so in case anything did happen.
I also made a copy.
I'm sending it to you.
Oh, okay. I found the older version. It's still a version type. It's still a version type. So one identification where you might see this is in different types of reefs. They usually reefs they will not choose an image to describe it, but rather they would actually like they would just give a description, and the descriptions you already see here what the descriptions are. The to give a basic a rough explanation, it's basically just like the pattern of how the reef eventually like what happens to the reef over time. But like that's basically what these four different types represent. And the second part is the other one besides there's actually two more identification. This is the second one they usually have. It's circulation. This circulation is always trying to. It's not about whether. It's not like hot and cold. They don't care about that. I mean, they do care about the direct. They care about the arrow direction. But the key part is basically where the where like the different types of circulation areas. Like this is a really bad one. Pacific Ocean, Indian Ocean. I believe a better one is like. Did we have a better one? There was a better there's a better image of this, and it comes right here. This is the better image of the gyros and the circulation. This is the better image. You can see how well in this case you can see North Atlantic, South Atlantic, Pacific, North Pacific, and the South Pacific Indian. These are like the five main ones they usually ask you to identify, and that's pretty much it. You need the other key thing is knowing the direction of the arrows. That's like the that should be like a given. Like it should be known that if it's in north, you do right. If it's in south, you do left. Like that should be a I mean clockwise or counterclockwise. It should be like a given knowledge that you know this. Like this should be like in your head at all times. Usually helpful. And then the other form of identification, technically, uh, waves are another identification. But it's not. It's a really easy type. Like these different types of waves. It's really easy. If you're going into eighth grade, you actually learn this in science. So like it's even easier than you can imagine because you learn this in science. So like you'll probably know this by the time competition because like I think we learned the first trimester, and then that is like there's only one other identification, and that's just there's just features, and these there's just features. So like there's the features of like the bay, like the sea stack, sea arch, sea cave. It's usually kind of hard to actually figure out what these are. So and they usually only have like 10 different images that they can choose from. So it would be best if you got all 10 of those images in your binder. But most likely you can probably tell which it's like if you look at all these diagrams, you can pretty much tell like most of these if you tried hard, you wouldn't be able to figure it out. But like, you should just have these diagrams because usually they just copy and paste different diagrams. They don't make their own. So you can just like take these diagrams, or you can memorize these features. Memorizing the features would be best, but they're kind of hard to identify. Unless we haven't had this in our binder previously, but if we had an entire list for like what a bay looked like, headland looked like, or marine terraces, that would be nice. But just an image would probably be more than enough. And then lastly, it's usually just diagram of the ocean floor. This is like the most used one. I don't know why. I don't know where I found this. I remember finding this image ages ago, but this literally is just like one trench, and then this example of how the ocean trench works. I mean, not just like basically just what a diagram of the ocean floor is like, and this is all it is. Like this, you just need to memorize like what the rough features are. Like, does it stick above the water where the ridges are located, and where it is approximate to the land and shore, and how deep it is. Or basically, this is literally the entire diagram, and this diagram is actually reused like for all competitions. I don't know why. Like, there's a black and white version of this. I don't know where to find it, but that's pretty much. I accidentally did that. But that's pretty much it. That's pretty much it when it comes. That's pretty much it when it comes to diagram identification. Yeah, that's pretty much it when it comes to diagram identification. So if I go back to the rules here, when we see that it's communicating, classifying, inferring, measuring, I don't even really. We did this. Okay, so that's not really it, but basically the three parts, as I said before, is multiple choice, short answer, and identification slash drawing diagrams. The diagram, the diagrams usually, it's usually about how it's usually I need to find a good image of this. I don't know if we have. Yeah, it's usually about how water temperature relates to the increasing depth in the thermocline. This is like the only thing they usually test on for diagrams. Like, this is the only thing they test you on. Sometimes the proctors are really mean though. So you might, because the thing is that they don't like how, if you like, maybe if you don't get the scale like perfect like squares and like maybe the rectangles, and like the scale is really off, the proctors may not like it because it looks different. Like, when you draw this line, it will look different. Like, it will just look different due to scale, and that's, you usually want to keep it in a square format scale, and that's the only other diagram I remember ever being taught. And okay, so these rules, I wouldn't trust most of them. See, in like 99.99% of events, not only they don't. Okay, so these invitationals, there's like invitationals, and then there's going to be that real regionals and like state. We didn't get state but this year, but regionals, state, and like uh, the invitationals. The invitationals themselves, they're not Okay, they're bound by the rules, but not by a lot. Like, they can do anything that's related to the empire. They can grab something from Division C, grab something from college, and they're expected to know it. So most of this, even though they say like bro, what is even even though they say that these rules, you should always look at Division C. You should always look at Division C. No matter for what event, Division C will always be on those invitational tests. If you want to do well, always look at Division C. Most kids do not look at it because, like, Division B, they can only test as Division B. No, 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 that's a complete BS lie. I don't know who tells them that. But they test Division C and invitationals. It's to challenge yourself as the reasoning given. And it's very good. Most of these, we have most of these inside our binders, but we don't have for such a, we do have all of this inside our binder currently, but like, wait, I can't. But we need like a more like we need like the one of the things that we did lack last year was in the identification category, and that was like, they gave us one of the things they asked us to identify is that we really don't know a lot about, that I would suggest for this year. What was it? Actually, I should open up a whiteboard because this would be like, wait. One of the things that I believe that one of the things that it was lava. It was lava identification. This is one of the things. This is one of the things we lacked last year, and this is one of the things that's not really stated in the rules, but I can almost guarantee they always test us on this. They always test us on lava identification, and lava identification is really something that it should be not really invested, but like look into. Like, it's something that it's actually kind of hard to identify these. Like, lava identification is actually harder than it looks. When you search up lava identification on the internet, you will not find a lot of information. It is extremely hard to find any information without pirating a book. Like what are you gonna, like, if you search it up, half of this won't tell you exactly. They don't even show the lava themselves. So like, it's not really helpful. Like, most of this actually. Like, the best way to find lava identification in like any area would be a textbook, but you might have to pirate that, but that's it. I don't recommend that, kind of. So yeah, and the key part is that we have to look at Division C, and that many of these events are not bound by Division B. Like, they're just not bound. They can do anything they want as long as relation to oceanography in this case. And in the case of, and that's pretty much it. A more detailed explanation of what's going to happen is in the bottom area here. The bottom area here is basically just like identification. Most of this is about identification, memory. It doesn't state memory. It says relate trends. Trends is logic. In my perspective, trends does not mean like, okay, trends is looking at like how the relative of something affects is in correlation from the other, but the trends usually just means logic. If you see something increasing, why does this affect something? So like, say like the number of fishes were dying because there were some global war because of the earth is getting warmer. Now that might be true, that might not be, don't quote me on that, but like the key part is that the key part is that you would use your knowledge on like ocean temperatures and try to hypothesize about that, but I have not seen a test do that. Most times what they're trying to do is just give you an interpret like data you see, and just try to see which one's the greatest one. Like, it does not go that deep into it. And you could technically get the CD, but I don't really believe you need that. And that's pretty much overview. This is like the shortest rule book I've ever seen. And then besides that, when we go into dynamic planet itself, one of the things that I believe is like how to like split this up is well, it's not really split up, but how to split up your research. How to split up your research is probably an identification, and identification and like just memorization. Memorization is like, it seems like they're very like similar, but like you need this is how I would split up my studying: identification and memorization. Identification is built. Identification is like identification is built. Wait, what? Why is it not typing? Identification is built on memorization, but you would first the key part is that in every test there's identification, memorization. Now, to get into like the basis of what the identification memorization is, you basically have. Actually, I should just tell you what that is. Oh, this is so useless. I just need a Google Docs. This is not helpful. Okay, so basically for identify, I think everyone can see this. Wait, can you see this, Aditya?
I can hear you.
Okay, so identification, memorization. In the case of identification, I will label identification as law of identification. This would go into multiple categories. You don't have to split into parts, but this is just you can use this for parts. This is used to split to parts. You don't have to do this, but maybe use to split this to parts, or split how you study. Like, it's how I approach this. Law of identification, diagrams. This includes circulation, gyres. I'm pretty sure you guys know the different types of fault lines. I'm pretty sure you guys know this. I'm pretty sure like from these words you can like tell what they are. Besides transform, that's like the most basic knowledge. And then gyros, you pretty much want to know the map location. Map location. And then circulation is just, you want to know A, hot to cold. B, gyros, you want to also know direction. Hot to cold. But for also circulation, you want to also know the circulation. You just want to know where the hot and cold like meet, and like where they are located in the circulation. It's not really easy to explain. Well, I think there's an easy way to explain it, but like a better way to explain this is like, say there's like the Gulf Stream. There's like a Gulf Stream. It's bringing in. It's like you want to know if this is bringing in hot or cold water. Bringing in hot and cold water. That's one of those things that I believe is like something you should like. This is like it's not like just Gulf Stream, but like your other types of streams. Like you should know them, and then like that's pretty much what it goes for. Oh, diagrams. This is like something that goes in between memorization slash identification. There's these like things that I would call like borderline, like both of them like categorizes it as. You would have. Wait, yeah, you would have. I'm being really dumb here. Okay, waves, and like, oh, and like, what? Relation.
Consequences?
Yeah. Relation how the moon. Oh, I was about to say how the relation affects the waves, but like the same thing. Neap tides and what was the other one called? And spring tide something. Yeah, spring tides. That. Okay, be spring tides. Relation how the moon affects the like this. This is like borderline. And the other one, the waves. I don't mean like waves, but like scientific waves. Like, i.e. example. I.e. would be like it would be like it would just be like amplitude, period, wavelength. This type of stuff. This type of stuff is like you could also memorize at the same time. But like back to identification in this point. Identification, it's mainly just circulation, jaws, and fault lines, and this is, and then like also the thing I hate the most is that the geography is like the hardest part unless you know the diagrams. If you see the diagram before, it's like the easiest part. It's like you just copy and paste the answer. But if it's not the same diagram, it's kind of hard to tell. It's kind of hard to tell. So I would suggest studying on this because every test will always include this. No matter what test it is, it will always include this. We'll always include this. And then besides that, for diagrams, there's a lot of identification, and I believe that's pretty much it. Yeah. I feel like I'm missing something, but like I think that's yeah, that's it. Now, and then this is like there's not really a lot in between, but like, and then when it comes to memorization, well, I don't really want to. Mr. Matteau probably won't like me calling memorization, but it truly is how good you It's not. Yeah, it truly is memorization, or how good you know. That's basically what I'll call it. It's not really. It's pretty much the same thing, but in memorization's case, you would need to know. Wait, there's so much that comes to mind. Different types of reefs. Different types of barriers. Not like, wait, I forgot what they're called, but like different types of barriers, and then different. Circulation. Circulation is an issue. Circulation, El Nino. There's quite a bit when I'm thinking about it. Different like what do you call it? Water bodies. Different water bodies. Different water bodies. The key. It's mainly that it's like the effect, the cause and effect. There's quite a lot when it comes to cause and effect. When it comes to cause and effect, it's usually how temperature, salinity, and density affect what is around, what happens around. This is very true for history. This is a little bit off topic, but this is very important if you want to do good in history. Like, it's actually very easy to do tests. This is how I do the test. It's like cause and effect is a very important thing to think about. And in terms of density, I mean dynamic planet, it's not really. It's not like actual like there's so many causes and effects like a loop. It's more like just like how like the temperature affects something. It's easier to think of it as effect rather than like say like memorize it. It's easier to think of it this way. It's always easier to memorize effects. It's always easier than cause and effect. There's quite a bit. El Nino, how circulation affects, gyres. You may need to know. Global warming, though. I kind of. It's not. It's you. You may need to know. You just may need to know it. It really depends on it really depends. And I think I'm missing a couple of things. It's been a while. Okay. I pretty much forgot what. Okay. It's basically I only missed like two things. Currents. There's longshore. I'm pretty sure I only missed like currents. Oh, wait, no, I already talked about boundaries. It's just currents, basically. I'm only missing currents. It's basically currents, and then what's it called? Coriolis effect. Most of these are also actually under cause and effect. Most of this on the El Nino is also kind of under, but like El Nino is also not because it is like a set fact what happened during El Nino. Like it's just a set fact most of the time. And then like oceanic tools. Oh man, there's so many stuff in dynamic planet that you kind of forget some. And then and it's just heat. Well, it's just heat. And this is like the main things I would believe are what you need to know. It's basically this. It's actually on the dynamic binder. I'll post this thing, but I don't know what the heck happened to this because all the images have been deleted or something. But yeah, and it's basically on this, and I'll probably share this as a separate document if you're interested. And this is basically the key part to it. So I guess, wait, what did David explain to you before? Wait, Aditya, what did David explain to you before?
We didn't have a meeting yet.
You didn't have a meeting at 1?
Not that I know of.
You should have just explained like what we should study.
I think there's something weird with David's thing because if you look at the time section, it says 4 o'clock Pacific time.
Some schedule change happened last moment. I'll tell you that. Okay. So this is a little bit off topic, but if you want to volunteer, you guys are going to 8th grade. A really good way to start high school is that in 8th grade, after 8th grade is graduating in summer, you should always start volunteering. And I'm doing STEAM for all, and that's basically taking time up. But for Dynamic Planet, I guess what I'll start I'll start with. Now, I already explained to you how lava identification is a tricky part. It's tested. It's actually worth quite a bit, but it's not something that it's really hard. It's something that you have to just search and find. Like, we had only one image last year. I found only one image that I pirated off a book because that's the only way to find some of these things if you pirate off an oceanic book. Yeah, this is the thing I found. So this is the only thing I found. This diagram right here. It's one of the only things on lava types. Lava types, I would recommend lava identification. I would recommend a textbook because this is farther than what dynamic planet is meant for. But technically, as part of dynamic planets, I would usually just recommend oceanography textbooks. I pirated mine, but you shouldn't pirate. You should actually go to the straight source and figure it out how to get it. But you can get it from Mr. Mateau. But the key part is that identification is something else. But diagrams, the circulation. I'll probably start explaining that. So basically, the diagrams. Oh my god, the PDFs are so unreliable. I think you can open this in Google Docs. Oh, I'm so dumb. You can just open this in Google Docs. Oh no, it looks so bad in Google Docs. Never mind. So basically, for circulation. Basically, I believe your science teachers in 6th grade may have taught you this, It's always from hot to cold. Like that's just how everything in the world works. Well, most of the well, he always travels to the coldest areas. That's why when you like say you get cold, the reason why you feel that you seem to get cold is not because the cold is coming to you, it's because the heat is getting lost from you and bringing out the cold. That's the things that you may want to know. It's just something to keep in mind that everything goes from hot to cold. It's pretty important. It's actually very important for like more other physics events. But if you look at this diagram, basically, what basically happens if you can see it is that it basically always goes from hot. Basically, there's like two well, it's not really hemispheres, but basically what happens is that if as you can see, usually what happens is that either the cold is changed to hot water, warm water, or the cold water, or actually it's hot water getting changed to cold water. The most significant areas you need to know is that basically when it goes from North America to Europe, this is the key part. It brings in hot water, and then it brings back cold water, and then in the Indian Ocean, any area around this part, because usually what happens to circulation is that they do not ask like true and false multiple choice. What they truly ask for is like short answers on how does this bring warm water, what happens as a result, and like you need to know. It's key to know that the warm water is brought to Europe. This is the most tested one. Warm water brought to Europe, and you can. This is one of the most important ones. The other one that you won't really see is the Pacific Ocean. It's how like there's this it forms like this, like not gyre, but like you can see like it forms a circle. It is like you may need to know this, but there's a Great Pacific something bin. What's it called? Garbage patch. This is it. Great Pacific Garbage Patch. You may need to know this. You may not. But basically, because of the gyre here and like the circulation, there's like this Great Pacific garbage patch here. But that's not too important. But what happens is that you need to know that the hot water that comes from here goes straight under above Australia and goes to the Africa. You need to know these geographic locations, mainly because these questions test on these geographic locations, and many of these ask if it's warm water or cold water brought in terms of identification. It's not okay. I could add it to my list, but it's not really identification. It's more like if you can picture this in your head, you're more than easily enough able to do this. And the circulation, thermohaline circulation, what you need to know for that part, besides like the location of it, is density, salinity, and temperature in the water. And well, in the case of thermohaline, it's basically that it's temperature based and like salt content, and the temperature and salt content is what directly relates to the density, and that's basically what you need to know that affects it. It's basically density, salt contact, salt content, and temperature. These three things are like what affect the thermohaline circulation. These thermohaline circulation is basically just transports water around, and the cause of this the cause of all of this comes down to two things. I believe it's the Coriolis effect and the sun. The sun itself, the heat it brings, the wind itself. That's exactly what causes. That's what causes. Like the sun is part of it, but it's also the Coriolis effect that causes these different directions. But that's not too important. The key part is that the sun, the heat that brings as the form of like wind, is pretty much what like starts all this. But like the marine circulation is not really based on it. It's based on the temperature, salt content, and density of seawater. And as you can see here, that's exactly what it is. And it's basically just a great conveyor belt. And then the gyres in part of this next part of circulation basically is about how it's not it's basically just from hot water to cold water. It's not too important. You just need to know that the cold water is always on the usually on the right side of the gyre, and then the warm water is usually on the left side of the gyre. So as you can see here, it's a very easy way to memorize. Look, the cold water is always on the right side, or like semi right side. Like you can pretty much tell what I'm trying to say if you looked at this diagram. And the Coriolis effect basically makes it so that the different equator sides bring in a different direction. You just need to know north is clockwise and south is counterclockwise. And then there's just a current that from Antarctica that basically brings all this cold water. But yeah, and that's the Coriolis effect, as you can see here. Basically, it's just the actual, basically how like at the equator it splits off into different directions, and if you if you can visualize this, you'll realize that they're actually different directions. So then, uh, yeah, and that comes down to circulation, and I've already explained gyros. I believe fault lines. Everyone should know this by now. If you don't, you probably wait. Did you guys learn this in seventh grade science? I'm pretty sure you guys learned this in seventh grade science. Did you guys?
Yes.
Yeah, I'm pretty sure you guys learned this. Well, basically, it's extremely easy to memorize. Actually, like they explain this in like every type of science activity because all the teachers know this at any point. Wait, I can't find it, but like basically, what a good way to like put in it to like show this like uh a good way to like show like basically is that if say you have like rich here and then you go boom boom say like there's like this uh say like these are like two tectonic plates. I believe okay, tectonic plates. I believe everyone should know this from okay. Everyone everyone should know this, but basically you know what tectonic plates are by now, I guess. Hi, I'm pretty sure everyone should know this, but like it's just like tectonic plate A, and then yeah, this is like tectonic plate A, and then yeah, and this is tectonic plate B. Tectonic plate B, and basically you already know what tectonic plates are. Everything is basically moving on top of it's just the crust moving around. The crust is just big plates, or you can think of it as big rocks, big flat sheets of rocks that move around based on the magma that's underneath. Like there's a liquid. The reason why it's on is gravity, but that's not too important. The key fact is that the different types of earthquakes. If you guys haven't learned this, it'll be like the most quickest review. When like just like the name goes, divergent literally means just diverge. Convergent, and I'll show in blue. Convergent means to put in blue, and to put in blue, this is what convergent means. And then transform, the easiest actually the easiest way to visualize this is say we have like two like plates. This is so inaccurate, but like two plates that look like this. It would mainly be how one plate goes the other way and another plate goes this way. This is like the three ways. It's very easy to memorize: divergent, convergent, and transform. You don't really need to know what transform is because you could just say it's not divergent, it's not convergent, it's transform. And that's basically how you. It's very easy to identify. You should all get 100 points on this. And if you want to know the history behind this, it's pretty simple. Pretty sure it's discovered by this guy. Who? Well, you guys learned this. I completely forgot. Who was the guy who discovered tectonic plates?
Alfred Wegener.
Yeah, Alfred Wegener. Yeah. He survived. He who you basically just need to know he found this out. You don't really need to know anything but that there are tectonic plates. And then the other thing with tectonic plates is usually comes with the identification of them. This is mainly what you need to know. Tectonic plates. This is like the only other thing I would believe you need to know. Just some. This is like the only thing I'll tell you that you might need to know, because another thing that you would also you might encounter is why is the Pacific plate, why is there a ring of fire, like something like that. The answer to that is pretty actually kind of simple. It's basically all around the Pacific plate, which is extremely big, but because it's extremely big, it's surrounded by all these other continents that causes volcanic activity, which is the main reason why. But that's basically the simple explanation. That's what you need to know, the ring of fire probably, and you probably just need to know these plate names. You in the case might be these smaller plates. These smaller plates usually have special phenomenons that go in them, and I'll suggest looking into that if you truly want to get like that first placer. You probably don't need that. And because I've explained fault lines, it's probably geography. So geography, it is the hardest one, as I said. There's no other way to do geography but to research. Like geography just comes down to research. Like all of these images, we only figured out we actually needed this after the first two competitions, and all of these geography is literally just how like it's just coastal lines, and or coastal erosion, same thing, or not the same thing, but like same idea. And then you have ocean floor, and those are the two things looking for: ocean floor and coaster features. Like that's the only thing you pretty much need these diagrams for. And then yeah, pretty much. Now on to memories and identification. I'm gonna go more into detail later. This is just gonna be an overview class because I don't want to go too into detail because I believe everyone's gonna have like questions if I go too into details. But for the memorization slash identification, the waves I should basically if you like say they like I like a wave is basically just like S for time, S for time, and like H for height, and basically it'll just be like usually be like this. Oh, wow, that's such a good drawing. So then you usually have a wavelength between these two. That's the wavelength. Amplitude, I believe, is the height from this. That's amplitude. That's amplitude. That's wavelength. And then wave. Wait a sec. I feel like I'm being dumb right here.
That's not wavelength.
I know that's not wavelength. That's amplitude. I believe that. I feel like I've like.
Wavelength is crest to crest or
Wait,
toe to
what?
toe.
Wait, what?
The wavelength is either the crest to crest or the
Oh,
toe to
it is
toe.
crest to trough. Yeah. That's wave. That's
Height.
if you yeah. That's wave. Like no one uses wave height. Everyone uses amplitude.
Okay,
This is wave.
but this is not the wavelength. For the wavelength, you'll have to extend the line all the way to the other way. So,
Really?
come on, I can't annotate.
I'm pretty sure. Oh
Yeah,
no,
wavelength is
that's not. I'm confusing myself. I'm confusing myself. I had. Okay, that's perfect. I need a bigger diagram for this. Okay, wow. I haven't even used full zoom. Okay, so a better way to do this is like say. Oh my god. Say I have S and say I have height. That's actually a really bad way to do this. So say I have S and say I have S and say I have height. Well, I bet I'm gonna draw a bigger diagram because this would be like 10 times easier to visualize. And usually you're just gonna use this for this is mostly science. It's not really used in oceanography because there's way too many factors to take into account, such as like ocean floor levels. So like this isn't really used. There is math behind this, and you won't really need to know the math. The only time it uses math was at JT, and JT asked you to use stuff you shouldn't know right now. So that's basically it. So what wavelength is just you would need basically you would just know that this is just the wavelength. Wavelength, and then you would know that this would be you know that this would be I should use different colors, but like I guess everyone can tell. This just be amplitude. You should all know this by eighth grade science, but in case you're in seventh grade, this would be I guess this would be kind of useful if you still haven't decided. And then trowel is basically just like the low part. Usually these waves are repetition. So the trowel, if I can say continue this, if I say continue this, the trowel would also be here. Usually that's exactly the same with yeah, that's basically usually the same. They usually are continuous waves, and that's yeah, and then amplitude, and then it's kind of hard to label everything, but like you say these two are usually the same. They're labeled not labeled apex. I feel dumb. Crest. And then this is literally just crest right here. And with that crest, you also have you can call this x-axis. You can call this the x-axis here to be you can just call this x-axis to be the equilibrium. Though this will not be usually tested because all the equilibrium is basically where it's not always so in this special case here the only reason why this is the equilibrium is because basically what happens here is that It's usually just because it's basically where like say the wave. Oh, I didn't even label wavelength. Say this is wavelength is from the top to the most bottom part of it. The most bottom part of it. Okay, that's like the worst drawing I ever drawn. That's like you need to know. This would be a wavelength, and wavelength is usually you wavelength is to find that equilibrium. Equilibrium is just if you did if you did some math. I would if you did some math, it would basically be how it would be the equal x-axis is based on the x-axis, but that means that you don't really care about where it's located in the x-axis. Basically, to find it, you would be looking at the y-axis. You'd be looking at the y value, and the key to finding the y value would just be wavelength divided by wavelength over 2, or where wavelength divided by 2. It's wavelength divided by 2 would only find you the direct location in terms of the trowel. This would be like only finding, which would only find direct location in terms of trowel. Like it's only or crest. It's yeah.
It's wave height.
Oh yeah, wait, I'm so dumb. I'm so dumb. I completely botched that. Yeah, I completely botched that. Yeah, it's wave height. I was being, yeah, it's wave height. Okay, I already said. Oh, wait, what? It's like really tough to use all these drawing softwares. Oh my god, how do you even edit? How do you? I don't even know how to edit this. Oh, I know. I'm being so dumb today. It's wave height, and then I botched this, but basically it's wave height divided by 2. Wave height divided by 2, and this is only to find the direct location in terms of the trowel crest. And it's literally just, yeah, then basically direct location. And I believe this is all. Wave period is the only other thing. It's just how the time it takes. It's just the wave period is the thing I don't really want to draw because it's not really drawable. It's not really made to draw. So wave period is just equivalent to the time it takes for one full rotation, for one full like wave. So basically, in terms of this, it would be like something like this. But it would only basically this is what the blue represents. And then the wave period, I believe that's the wave period. I'm not being dumb, right? 2 successive crests.
The pass is specified.
Wait a second.
Um,
Wait. I'm
so
being dumb here. It's 2 of them, isn't it? Wait, is it 2 of them, Aditya?
see, you start at the crest of this and end at the crest of this. You don't start from the trough and end at the trough. So your first one was correct.
My first one was correct?
So no. Okay. Can
Okay,
you
no,
erase?
I feel like it's just this, and I'm overthinking it. Oh wait, the way I draw it is also correct. Okay, so there's 2 ways to think of this. You can think of it as this, but you can think of it as this, or another way to think of it, like I just realized something. These 2 are exactly the same things, no matter how you try to interpret it. Okay, why is it green? That doesn't help me. I need like black. Okay, so when you look at this, the black and the blue are actually the same thing. This is I forgot this, but these 2 are exactly the same thing. I remember wait period. Wait period is just how long it takes for one, or you could say 2 successive crests. The reason why they mean the same thing is that if you think about this logically, say like you take this I mean, say like you take like you see like this the part I've squared. Say you've taken this square part. All you're doing to that is moving it to here. So that's literally all it's doing. It's pretty much the same thing in terms of this. And wait period, you might need to know Hertz. Hertz is more of a circuit lab thing, but I guess I can explain Hertz. Hertz is literally Hertz is equal to how many? I think it's equal. To, wait, no, it's not lambda.
One cycle per second, I believe.
Oh my
It might
god!
be.
I accidentally did something to my head. Okay, so I don't think. I don't. Wait, I don't. I think the textbook is making. I do not think. Yeah, I was right. It's how many cycles per second. I'm overthinking this. Okay, so there's two
I
ways. You
think
can use. Yeah. Well, oh, you're right. Yeah. I think right. That's what you meant to say, right? Or
yes. Time it takes.
yeah.
So hertz is one cycle per
Yeah.
second.
You don't need wave speed. I've never seen anyone use this at all. I've only seen hertz. Hertz is the very most conventional way to do this. Hertz is the most conventional way to do anything these days. I would recommend hertz. I do not. Wave speed. I've only seen it once. It's wave speed is actually the application of wave speed is usually used as a tool to find like wave speed is equal to lambda over. How do you spell lambda? Okay, I was right. Lambda over wave. It's just wavelength divided by wave period. Wave period. And I don't think you need lambda, do you? No. Okay, that's not too important. But
No, no,
wave speed. But the
no.
point of wave speed is it's very similar. So hertz in this case. I need to move this. So hertz in this case is to find number of cycles per second. But the only reason why you need wave speed is because it's used as a tool to find hertz. Well, you don't really. Well, technically, it depends. Number of meters per. It's pretty. Yeah.
So if the wavelength is 1 meter, then I guess period would be the same as wave speed.
Uh wait.
If it was 1 meter, then one cycle would be 1 meter, right? Oh yeah.
Wait. Let me think about this for a sec. Oh, whoa. Wait a sec. Are you sure
If
this
one
formula is
is
right?
one
Are you
meter,
sure this formula is right?
the formula is right.
Well, the issue is that the x-axis is always time though. So how the heck is it measuring this? See, wave period would be the time it takes for two successive waves, right? So you're literally what? Okay, so I'm not
No,
very
no,
confused.
it's really one wave if you
It's
think about it.
wavelength
It's
is in this case
because of
seconds.
cracks.
It's seconds divided by meters per second. No, it's seconds divided by
So this is wave speed, right? That's just
wave period is time it takes for.
seconds times. Oh man, that's weird.
Hey, what the heck is this even fun? Where you see how to do science correctly? This may be a little bit off topic. How to do science correctly, especially in chemistry, is to always include the units and think, why? How does acceleration work? Like for example, it would always be like a speed, velocity over time. And why do you know this? It's because it's equivalent to meters per second divided by second. Divided by second. Like that's just one way to do it. You'll learn this in 8th grade, but actually in science of all things. But I don't know why this formula doesn't. Okay, but just use this. It's related, but like it's just. No, wait a sec. What does wave speed even find for you there? Wait. What? How does that have anything to do? So basically, according to the textbook, I don't get the units right now, but it's according to the textbook, it means distance per second. What it does not necessarily mean meters, because distance per second, and that's in the case of this. I'm gonna move this a bit. Oh my god, I'm gonna move this a bit. Why does it have ed on there? Okay, I'm gonna move this a bit, but like basically, you can tell what basically how the basic of the wave itself. And this is the waves, and I don't have a lot of time left, so I'll basically I don't want to get to the knee pads. I guess I'll explain more in circulation because there's a little part I want to explain. So circulation is not limited to just like the overall picture. No, it's not really. It's actually technically it's hot and cold, but like I can't. I'm gonna take a screenshot of this and post this later, but I have to delete everything on here. Basically I'm gonna start like but pretend this is like say have like say this is like my shore. They say this is like my shore, and this is like my waves part. My waves part here. They say this is like water coming into the shore. Say this is water coming into the shore, and to draw the water, you would say like the water is going in. Key understanding is that uh, usually it goes like this most of the time, I believe. But it rises from the bottom. The key it usually goes like this. That happens for most waves, and usually a better way to like from a 2D picture. There's not really one way to do 2D. So 2D is that's just one phenomenon to know. But in like from looking from above, there's different ways it hits the shore. One way is that when it goes up to here, it immediately returns back. Say like this is the shore, this is the shoreline. The shoreline is this black line. But sometimes it would go to here, and sometimes it would go beckon out this. Well, yeah, it would beckon out. Well, it's not. Okay, technically, it would eventually go back out, but like for the sake of what Proctors want, it would always it's gonna basically go like this. These you have to like think it's not it's usually this is how like the other I'll talk about this later, but it's next at the next lesson, or maybe David will talk about this tomorrow. But what happens basically is that when it hits the shoreline, there are different phenomenons that occur, and it's something to think about. I don't think I'll give you guys homework this time. There doesn't seem to be too many people, so I think grading the homework would be kind of pointless. But do you want homework, Aditya or Daniel?
Not necessarily, but we've started a new binder.
Yeah, I guess everyone already has the binder, so then it'll be kind of pointless because this is memorization based. But I guess the key part to think about for next lesson, or whatever David want, or whatever thing David's gonna teaching, is circulation. Because wave is pretty simple. The math part I wouldn't worry too much. Math is very little, so like don't worry too much. Like do not worry too much. The reason why they allow any calculator is because they know you're not gonna do graphs. So they know you're not gonna. Do not worry too much. Best case. So what you need to focus on is circulate the most. What I would like to see is circulation, and then circulation, and like the diagrams would be key. But we haven't learned all of them, so I'm just gonna say like not shoreline features, shoreline features. Just to think about. This is stuff to just think about because I'll probably go into this more deeper. But shoreline features and ocean floor. I'll explain just how this works. Maybe I'll show a video. But just think about circulation, shoreline features, waves, and a key. And like and then for next lesson, I would beside that, I would like yeah, it's basically just circulation. There's two things I'd like to see. What I would like understand is the it's basically this is actually technically agenda or slash what to think about is Cariolis, and then the gyros slash the three parts that are the most important in my opinion are salinity, temperature, and density. These are the things that you should always have in mind, no matter what. And then and then the last thing that this is probably an agenda for next time will probably be I think I'm missing something. Wait, I had something in my head. Circulation, diagrams. There was something in my head that I was thinking about, but then I just lost. Okay, I'm just gonna go a little over time. Diagrams. There's something really important in my head, like shoreline, diagram, circulation, salinity, temperature, density. Oh, so there's different layers of the ocean due to the temperature and salinity. This is something we'll get into later. Not really, actually, yes, salinity and temperature, salinity and density. It's interconnected, which is something I'll explain later. I'll explain later how this is all connected, but like I'll explain later. But like I think I can do this. I think I can bold. Can I even bold text? Okay, no, I can't. I gotta like do Control B. Okay, but like the key part is to see the relation between this and different parts of the ocean. This is just something I want you guys to think about, and that's basically it. What to like basically practice on what to also think about would be shoreline features and ocean and waves, reviewing waves, and also reviewing like the overall basics about how it's identification and memorization, and that's is all I'm gonna have for today. I'll be posting this recording, but I bet 2 out of 3 are attended, so I wouldn't see the need for that. But okay, I'm probably gonna end this or something. Are you good? Is that good? Is that good
Wait,
or?
hang on. Do you exist? Oh,
Yep.
good. In the call.
Oh wow, you want to leave so early? Okay, whatever. Bye, DTR.
See you, Howard.